Welcome to the video on dimensional analysis. We will start this video off with a few answer keys from the homework packet, and then we'll jump right into solving dimensional analysis problems. So if we look at the answer key to this practice set from last video, the answers are shown here. The next practice sheet, the answers are shown here. The first one is 1.9 grams of omega fatty acids in 100 grams of fish. Anytime you have a percentage, you can put that number over 100. And then you have to figure out the units for the percentage number on top and the 100 on the bottom. So 1.9 grams of omega-3 fatty acids in every 100 grams of fish. And then you can flip it. In one capsule, there's 360 milligrams of omega-3 fatty acids. There is 0.125 milligrams of levsin in every 1 milliliter of solution, 85 milliliters flowing every 1 hour, and you need 60 milligrams of vitamin C each day. So please forgive me with all of these red marks in the wrong place. So welcome to the video on dimensional analysis. In this video, we're going to talk about using conversion factors to get from something we're given to something that we want to find. You may have also heard this called the factor label method. And honestly, you don't even have to understand what's going on. You just have to look at the units. So you'll be given some unit. We want to find some unit. We will use a conversion factor to convert our given unit into the desired unit. And of course, the given units will cancel and we'll end up with our desired unit. For example, if we want to know how many centimeters are in 15 inches, we start with 15 inches and we put over here, we want centimeters, and we're going to figure out what is the conversion factor that we can use to get from inches to centimeters, and that is the equality that there is 2.54 centimeters in every 1 inch. Notice that I put inch on the bottom so that it would cancel from the given unit. And notice centimeters is on the top, and so that's the unit I ultimately want. And so if we do that math out, we get 15 times 2.54, that is 38. And if we cancel the inches, we end up with centimeters. So that is a simple dimensional analysis problem. Now, if we go a little bit deeper into dimensional analysis. So the first thing we do is state the given and the wanted quantities. And so I always write what's given on the left-hand side and what we want on the right-hand side. That's units primarily. The second step is that we look at what conversion factors we need. There's going to be something here, potentially something here, all the way across. So then we look at the conversion factors that we need to get from the given unit to the one we want. The next step is to set up the problem and cancel the units. And the last step is to actually put the numbers through your calculator to get your final answer. And a final step that's not listed here is we need to determine the number of significant figures, write our answer in the number of significant figures with the unit, and circle our answer. So if we look at this example about Greg, who's getting a PET scan, Greg weighs 165 pounds, and the question is, what is his body mass in kilograms? So we're starting with 165 pounds, and what we want is kilograms. So that's what I want. So I have taken care of step one. I have the given and the wanted quantities. Now, what conversion factors are we going to need? Well, for this problem, we're going to need to be able to convert pounds into kilograms. And so we're going to need this equality right here, which is 1 kilogram equals 2.205 pounds. I'm going to set it up with pounds on the bottom and kilograms on the top because I want pounds to cancel and I want kilograms. So if I want kilograms, that needs to be on the top. And if I look at my equality, for every 1 kilogram, there's 2.205 pounds. We'll see that pounds cancels and we're left with kilograms, which is what we want. So I've set up the problem. So I've looked at the conversion factors that I need, and I've set up the problem to cancel the units. And so now I just simply have to calculate my answer, and I would take 165 and divide it by 2.205, and that gives me the answer of 74.8 kilograms. My 165 pounds gives me 3 sig figs, and so I report my answer in 3 sig figs with units and then circle your answer. So for the next problem, a total of 2,500 milliliters of boric acid antiseptic solution is prepared from boric acid concentrate? How many quarts of boric acid have been prepared? 250 milliliters is what's given, and they want to know how many quarts. The bottom line is how many quarts are there in 2,500 milliliters? And so we go to our handy little sheet again, and we see that for every 1 quart, there is 946.4 milliliters. And so I hope you see that we want milliliters on the bottom, which is 946.4, and we want quarts on the top, and that is 1. Milliliters cancel, and we have quarts, and that's what we want. So we simply do the math. 2,500 divided by 946.4. If I punch that into my calculator, 2,500 divided by 946.4, we get 2.641589 quarts. But if we look at significant figures, this has 2 significant figures, and then this has 4 significant figures. And so we want to stick with 2. So our final answer can only have 2 significant figures, which means that we have to round to this place right here. And so our answer should be 2.6 quarts. And that's our final answer. So for every single answer, you have to think about what's the value, what's the units, and what's the significant figures. So we'll do this last problem. A person who exercises regularly typically has 15% body fat by mass. If this person weighs 155 pounds, what is the mass in kilograms of body fat? So what are we given? 155 pounds, that's the full body, and we want to know the kilograms of fat. So if we have 155 pounds of body and we want to get to kilograms of fat, we have this 16% by mass. And so if we're talking about 16%, we do 16 pounds of fat per 100 pounds of body. And if we want to convert now to kilograms, we're going to put pounds in the denominator and kilograms in the numerator. And our conversion factor for that would be, for every 1 kilogram, it's 2.205 pounds. And so if I do that math out, the answer to this problem would be 11.247 kilograms of fat. And if we talk about the correct number of sig figs, we have 2 here and 3 here and 4 in our kilogram to pound conversion factor. And so we're going to report that in 2 significant figures. And so my answer would be 11 kilograms of fat. And that's my final answer. There you have it, dimensional analysis. This is a very useful and important tool that we will use through the entire course. So let's try to just embrace it and get comfortable with it. Awesome.